Okay, so in class we've been talking a lot about quadratics and the parabolas that they make and so on. Now we're going to start getting into all the different functions, families that we've talked about. We've talked about exponential functions, linear functions, and now quadratics. So now we want to focus on the difference between a linear function and a quadratic function. Linear function makes a line, and a quadratic function makes a U, either up if it's positive or down if it's negative. Okay? And one thing we need to remember about linear functions is, it's y equals mx plus b. And we need to remember that m means the slope or the rate. So in order for it to make a line, it has to rise and run or fall and run at the same amount every single time. However, for a quadratic function, it looks like this, right? So at some parts it's going to fall and then it's going to rise. So it does not have a constant rate. So what we want you to be able to do is to look at a table and determine if it's linear or quadratic based on its points. So here we have table A, which is function A. Remember, a of x, the function of x, can also be just the y. And same thing here at the B. So what we know is if it's linear, it's going to rise and run at the same rate each time. If it's quadratic, it's not. So what I want to do, look at this, is I want to figure out all my x's are the same here as they are here. I want to figure out what's the difference in these y's. So if you look at between here and here, it decreases by 0.25. So it has a decrease of 0.25. Okay, and then if we look from here to here, again, it decreases again by a negative 2.5. And then we find the same thing here. Again, it's decreasing by negative 2.5. So that means it's falling at the same rate over and over and over again. And you know that negative 0.25 is the same thing as negative 1/4. So it must be falling 1 and running 4. Okay, so because the difference is the same between every point, we know this must be a linear line. Okay, so whatever this is, this function is linear. So now we want to look at this one right here and see what is going on with this table. Again, the y's are the same, but now we want to find the difference between negative 15 and the negative 2.5, 7.25. So if we take negative 15 minus negative 7.25, we find that this is going to be a negative 7.75. I'm sorry, this is not negative, it's increasing, so it should be positive. And then from here and here, it's going up 7.25. And the difference between here and here is it increased by 6.75. And if we look from here to here, the difference is it's not working. It's increasing. If we take 13 minus 6.75, that is going to give me, what is that? 6.25. So that's going up by 6.25. So you can tell it's not going up by the same amount each time, right? It went up 7.75, 7.25, 6.75, 6.25. You can probably see a pattern there. But again, this one went up by a quarter each time. This was called the first difference, and the first difference was the same. Now this first difference was not. However, we can actually look at this and find the difference between each one of these. If we find the difference between 7.75 and 7.25, that is 0.5 or 0.50. And again, the difference between here is it's going up 50. And one more time, the difference here is it's going up 50. So now our differences are the same. So the first difference was a different amount each time. But the second difference was the same. And that happens with all quadratic functions. If you take the difference of the difference, and it is the same, this tells you the second difference. It tells you it is a quadratic function. So when you walk into class tomorrow, you're going to need to be able to give a chart, find your differences. If they're all the same, you know that makes it linear because it has a slope of rise and run the same. Now this one is different because remember, we have something that looks like this, okay? So when you're talking about if this was 0 and this was our -1, yeah, okay, and this was -2, you can see that this is going to be rising here, but then it's going to be rising this way as well, okay? So that's what you need to be able to do tomorrow. You'll be able to find the first differences. If they're the same, it's a linear function. If the first differences aren't the same, go ahead and find the second differences. And if the second differences are the same, then you know it's a quadratic. If these are not the same, then it's neither linear nor quadratic. It will be something else. Okay, so make sure you took good notes on that. Make sure that you understand linear is the differences are the same because of its slope. The slope has to rise and run at the same rate. However, with a quadratic, the second differences must be the same. Good night. Good night. See you tomorrow.